Exercise 165, page 419, question number 7. This one's a little bit more involved because if you look at it, I've got on the top here two functions, 2x e to the 4x. So I might and will have to use the product rule at some point in that when working out the differential of the top part. So what we have to write down is we let u equal the top bit and v equal the bottom bit as usual. So u equals 2x e to the 4x. So I've got to differentiate this. What I need to do is to think of this as a product rule. So we've got, I don't know, we've used u and v, so let's just say a and b. The letters don't matter. Don't even really need to use letters, because for the product rule, remember, it's the differential of it's the first bit, which is this bit, times the differential of the second bit, plus the second bit times the differential of the first bit. So we could almost just write down the answer. So what's du by dx? It equals the first bit times the differential of the second bit, which is 4e to the 4x, plus the second bit, which is e to the 4x, times the differential of the first bit, which is just 2. So tidying that up, we get 2 4s are 8, x e to the 4x plus 2 e to the 4x. Factorising, we can bring a 2 and an e to the 4x outside the bracket, leaving 2 4x plus 1 inside the bracket. So that's the differential of the first bit, the top bit, and I've had to use the product rule to do that. So now v equals sine x. So dv by dx is just cos x. So now we're going to use the quotient rule and put these all together. And what does the quotient rule state? dy by dx equals v du by dx minus u dv by dx all over v squared. So you can try plugging them in and then tidying up. So dy by dx equals v, which is sine x, times du by dx, which is 2e to the 4x, times 4x plus 1, minus u, which is 2x e to the 4x, times the differential of v with respect to x, which is cos x, all over v squared, and v is sine x, using the convention sine squared x. Now all we've got to do is try tidying up. So the algebra that's involved here, what I'm going to try and do is to multiply out this part of the function here, multiply out this bit, times by the sine x, of course, and then collect together like terms and see what we've got. So equals 2e to the 4x times 4x times sine x plus 2e to the 4x times sine x minus 2x e to the 4x cos x. All over sine squared x. Well, I can take well, I can tidy up this little bit here, because 2 times 4 is 8 e to the 4x sine x plus 2 e to the 4x sine x minus 2x e to the 4x cos x all over sine squared x. So e to the 4x is common to all 3 terms, and so is 2. So I can take 2 e to the 4x outside a bracket, leaving 4 sine x plus sine x minus x cos x all over sine squared x. I left an x off here, didn't I? Which means that there needs to be an x inside there with this as well. Right. So now, if we look at this, we've got 2 e to the 4x, and then inside this bracket, if we look at it, we can actually take the first 2 terms that's inside this bracket here, this term and this term, and factorize those 2, because sine x is common to both. So what we can do is we can take the sine x outside the bracket there, and then leaving inside 4x plus 1 minus x cos x all over sine squared x. And that's the solution in the textbook. Although, of course, any of these solutions are correct, and we might well want to factorize slightly differently or leave it in a different form depending on what's coming next. All I'm doing here is trying to get it to look like the solution in the textbook. Of course, looking at the textbook, you can see that they've actually written it slightly differently, because of course, instead of dividing the whole thing by sine squared x, I could just divide the 2 e to the 4x by sine squared x, which is just what they've done. 2 e to the 4x divided by sine squared x, and then multiply that all by this bracket. Sine x bracket 4x plus 1 minus x cos x.